Ooh, well, this is looking a little blurry. There we go. Okay, so continuing with hodgepodge, this will be part 2 of our little hodgepodge unit. And I want to talk about rationalizing the denominator. But first, I want to show you guys some of the rules for square roots. So, rules for square roots. Okay, rules for square roots. Ooh, I'm not good at writing in my notebook. Okay, so our first rule would be that if you have rad A, I'm just going to call it rad A, times rad B, it's the same. You can multiply them. Imagine them both in their little armored trucks. Well, they get along in their armored trucks, so you can multiply them together. And that would be equivalent to A times B under the radical. So let's look at like a real world example, because it's great with letters and all, but let's talk about it as if it were an example. So if I had rad 2 times rad 3, I can actually multiply those, and it would be rad 6. And if I could simplify that, that would be ideal, but I cannot simplify rad 6. So let's say for our next rule, we have A, which is not in a radical, times rad B, which is in a radical. Well, that would simply break down to A times rad B, and that would be how you would write it. With numbers, this is what it would look like. 3 times rad 5 would simply be 3 rad 5, or 3 times rad 5. What about if I were, this is my favorite one because it always confuses people a little bit, but once you grasp it, it makes perfect sense. So let's say I had the square root of A and I squared it. Well, that's simply rad A times rad A, which would simplify down to A. Okay, let's look at it as if it were numbers. So I had rad 7 times rad 7, which should be rad 49. Well, hopefully we all know that the square root of 49 is just equal to 7. So if you ever see a radical and it's squared, it's simply whatever the number is inside of that radical. So those are some of our rules for square roots. Now we're going to get into rationalizing the denominator. Okay, so rationalizing, I have a little clip here I need to move. The denominator. So here's the big thing. You cannot have a square root in the denominator. Okay, so what do you mean, Mrs. Black? Well, let's look at some examples. So let's start with example number 1. We have rad 3 over rad 2. Okay, great, Mrs. Black, but how do I get rid of that radical on the bottom? I don't know. I'm new to this. So what you're going to do is you're going to take that radical that's on the bottom and you're going to multiply it by the top and the bottom of your fraction. And remember, I told you you could multiply rad 3 and rad 2. That would simply be rad 6. Oh, why did I multiply that? And then rad 2 times rad 2, well, remember, that's simply rad 4, but we would take the square root of 4 and we would have rad 6 over 2, right? Remember, the same radical times the same radical is whatever that number is inside. You just get rid of the square root. So right here, you cannot simplify further. This is your answer. So cannot simplify further. This is your answer. Okay, let's try another one. I have a few of these for us to do, so hopefully you'll have the hang of them by the end. Let's say we have, for our second example, we have 3 over rad 2. All right, again, I'm going to multiply the top and the bottom by rad 2. Whatever's on the bottom, we multiply. So I would end up with 3 rad 2 over, well, rad 2 times rad 2 is simply 2. Or in case you're wondering where I got that, remember, it's technically rad 4, but we take the square root, and that's where I got the 2. And you can't simplify anymore. Some of you guys might be thinking, well, 6 and 2 are divisible, but you cannot divide that because this radical protects it. The only thing that can mess with it is another radical, and this 2 does not have another radical. Same here. This 2 is protected by this radical, so these 2's can't cancel out. This ends up being your answer. You cannot simplify further. All right, let's go ahead and do number 3. Let's say we have 5 over rad 5. Again, we're going to multiply both the top and the bottom by rad 5. And we will end up with 5 rad 5 over 5. Well, this time they are both outside of the radical, right? So these 5's would cancel out, and this would simply be rad 5 as your answer. Okay, well, why don't you try, or let's move along to this one. We've loosely gone over simplifying radicals, so this is going to incorporate both rationalizing and simplifying our radicals. Let's say we have rad 4 over rad 3. I would multiply both the top and the bottom by rad 3. 2 radicals can be multiplied, so that would be rad 12 and over 3, right? Rad 3 times rad 3 is 3. Well, 12 can be simplified. So let's go ahead and we'll just make a little factor tree over to the right here and think of the biggest perfect square that can go into 12. That would be 4 and 3. Well, in case you're stumped, oh, what's the square root of 4? Remember, it's 2 and 2. Because it has a buddy and this is a square root, the 2 would come out. So we would simply be left with the square root of 12 would be 2 rad 3 over 3. And that would be your answer. All right, let's try another one. This time I want you guys to try it. I'll go ahead and pause, or you guys pause it in a second after I write it down. So go ahead and do rad 2 over rad 10. Pause me and see if you can try this one on your own. Okay, well, if you need the guidance, that's totally fine. So I'm going to do rad 10 and rad 10. I'll end up with rad 20 over 10. I'm going to kind of simplify the 20 down here just in case you guys are a little stuck on that one. So 20 would be 4 and 5. We know that the square root of 4 is 2, and the 5 would stay inside. In case you're wondering where I got that, it's just the 2 and the 2, and over 10. Well, these can be reduced, 2 and 10, right? So the 2 would become a 1, and the 5 would become a 10. Yes. So we would have rad 5. We don't need to write that 1 in front, over 5. And that would be our answer. Okay, let's go ahead and we'll do a couple more, and then hopefully you guys will have the hang of it. So let's say we have 6. our problem 6. And we have 2 rad 12 over 2 rad 15. Yikes, Mrs. Black, you just had to make it more complicated, didn't you? Sorry. All right, so we're going to take rad 15 and multiply it by both our top and our bottom. And I just lost my place in the notes. Oh, there we go. Like, where did that one go? Okay, so 2 would stay the same. It stays out. Rad 12 times rad 15 is 180. And then rad 15 times rad 15 is simply 15. But don't forget that 2 that was out in front. So those will need to be multiplied. So we're going to end up with 2 rad 180 over 30. All right, we're going to simplify 180. So if you're thinking of the biggest perfect square that can go into 180, that would be 36 and 5. All right, so if we were thinking 180, we wanted to think of the biggest perfect square that could go into 180. That would be 36 and 5. Well, the square root of 36 is 6. So that means I would have my 2, the 6 of the square root of 36, right? 6 and 6 would come out of my radical. The 5 would stay in it. And then I still have it all over my 30. Right, so I would multiply my 12 and my 2 and my 6 and get 12 rad 5 over 30. And then I would see that they could both be divisible they're both divisible by 6. So 12 divided by 6 is equal to 2. So that would become 2 rad 5. And 6 divided by 3, wait, what did I do? Oh, 30. 30 divided by 6 would be 5. And our answer would be 2 rad 5 over 5. Okay, kind of a little tricky, but just go slow. Honestly, just break it up and go slow. All right, let's do number 7. Let's say we have 3 rad 8 over 3 rad 12. All right, what I didn't show you in the last problem, but I do want to show you in this problem, is that these can actually cancel out. All right, if we were to do that here, we would have still gotten the same problem, same answer, so don't worry. And if you can also see, this 8 and this 12 can be reduced. So we're going to go ahead and reduce. We're going to see that they both can go into 4. So I'm going to divide this by 4. So I'm going to be 8 divided by 4 is rad 2, and 12 divided by 4 is going to be rad 3. Okay, so I've simplified this a little bit, right? I've seen that these can both go into 4, so I'm dividing. And then I need to get rid of the radical. So I'm going to do rad 3 on the top and rad 3 on the bottom. And I'm going to end up with rad 6 over 3. And that's just another way of simplifying if you wanted to do. Here you could have seen that the 2 and the 2 canceled out and that these both could go into 3. You could have simplified it that way too. Whichever way you're more comfortable with, you just need to figure out which way that is. So let's do our last example here. And I have 2 rad 8 over 5 rad 12. And this time I'm going to see that these both go into 4. Because they're both radicals, I can reduce them. So that's going to become 2 rad 2 over 5 rad 3. All right, now I need to get rid of this radical because there's no more simplifying I can do. So I'll multiply both the top and the bottom by rad 3. and I'll be left with 2 rad 6 on top. And then rad 3 times rad 3 is simply 3. So I'll take that 5 and I'll multiply it by the 3. And I'll be left with 2 rad 6 over 15. And that will be my final answer. And that is rationalizing the denominator. All right, guys, miss you. Please come to office hours Tuesday from 12:30 to 1:30. You guys have